Hi everyone, in this video we are going to discuss the schematics of a coal-fired power plant. So specifically what we're going to look at is the combustion of coal and the energy process it takes when the energy is released from that reaction, where it's converted all the way up to the electricity that then goes out into our schools, into our homes, into our work, and wherever. And so what we have to do is start off by looking at a bunch of coal that we are going to then set on fire. So we're going to start at the bottom down here and we're going to have some coal. So the coal is put right here and it's burned, okay? So some of these places can go all the way up to 600 degrees Celsius. It really just depends on the type of plant. So we're going to burn the coal or set it on fire, and all the heat that's going to be released in the form of energy, okay, is going to go up into this thing called the boiler. So that's going to go right here. So what we need to do throughout this process is talk about the type of energy that's released. So when we talk about coal to begin with, it is a fossil fuel, and a lot of fossil fuels have potential energy stored within their bonds. And so right now when we're sitting at coal, we're just looking at potential energy. Then we burn the coal and it releases energy into this boiler, which is essentially filled with liquid water. So this heat energy goes from the coal to the water in the form of kinetic energy. So what happens is this liquid water gets really, really hot and it is converted into steam. And so the steam is then funneled all the way into a thing called the turbine. Okay, so this is a pipe and it's going to take the steam from the boiler in the form of kinetic energy to the turbine. So here's your turbine. I draw a turbine like this. It kind of looks like, I don't even know, just a little thing that spins essentially. And so what happens is this steam in the form of kinetic energy comes in, it hits the turbine, and it forces the turbine to spin. So it's spinning, spinning, spinning. So essentially what it does is it converts kinetic energy to mechanical energy. So the mechanical energy is then funneled into the generator. And our energy goes from mechanical energy in the form of electrical energy, and that is what shoots out to us. And so we're really happy. That's me. Okay, apparently I have a mohawk. Okay, so it goes from the turbine in mechanical energy into the generator, converted to electrical energy, and that's what then goes out and goes to the humans, goes to schools, goes to wherever it is that you're at. Okay, we're going to come back to this process in a second to talk about how that actually works, but let's focus on the steam right now. So the steam goes through the turbine and it spins the turbine. Then what happens is the steam is funneled out into this thing called the condenser. So that's going to be right here. This is the condenser. So now, this is still steam coming this way, still traveling using kinetic energy. So it comes in here and it runs through this tube all the way to the bottom. Now what's neat about this condenser is it is also filled with liquid water. And so what happens is the steam is funneled through the condenser and it's covered in this cold water, and this hot steam eventually condenses and converts back to liquid water. So this liquid water then comes through here and then connects itself to the boiler, and you have this general cycle that keeps going and going and going. So the part that comes out of here is just liquid water. It's traveling in this direction, still in the form of kinetic energy. Now, where does this water come from? So what's really neat is you have this sink over here, or maybe you could think of it as a pool essentially, and it just has a bunch of water, and it pumps cold air in this way. So this is cold water in this way, and it's going from the pool into the condenser. So now this cold water is what interacts with the steam, and it forces the steam to convert into liquid water down here. But this cold water just fills up, and then once it gets to the top, it goes back to the pool. And so this is your warm water that is being released from this condenser, and it's going back to the pool. So essentially you have two major cycles that are going on here. You have a steam cycle, you have a water cycle, and then what's really neat is out of all this, energy is released. So now let's go back to this top part over here and talk about this part of the energy, because this is kind of tricky. So steam comes into the turbine. So this is just all these particulates or all these particles in the gaseous state. They're coming in, they hit your turbine. The turbine spins and spins and spins. So kinetic energy is converted to mechanical energy. Now, you have this turbine here, which is connected to this long piece over here, and on this end, you have essentially a large coil, or like a tube of wires. Think of it that way. So now, your turbine spins, it's connected to this piece. When this spins, it forces these coils to spin. So this is spinning, now this starts to spin. Well, this part over here, the coils, that's what's sitting in your generator. And so this generator has these coils spinning, and they are surrounded by a magnetic field. So when the coils spin within the magnetic field, it converts the mechanical energy into electrical energy. Isn't that cool? I think it's so neat. So you have steam coming in, kinetic, goes into the turbine, converts to mechanical, then the mechanical energy then converts the spins here in a magnetic field, which turns that into electrical energy. So all of this just because we are burning coal. How cool is that? All right, so let's see if you understand. We're going to do a couple questions here. First things first, we use fossil fuels because they are high in what type of energy? In blank energy. Go. Did you get an answer? Hopefully you did, and the correct answer is potential. And so we use fossil fuels because they have so much energy stored in their bonds. So within the molecule, within the coal, within the petroleum, or even natural gas, they have so much energy that's stored within that bond that when we burn it, it releases the energy in that exothermic reaction, which we can then take that energy and convert it into electrical energy. Kind of cool. All right, one more question just to check our understanding. So mechanical energy is converted to electrical energy. And I do expect you to fully know all of this, guys. You have to know the whole system. In the what? So where is mechanical energy converted to electrical energy? Bye, guys. Take care of yourselves.